Hello guys, welcome to this video. In this video we will be continuing all our previous explorations about all the functions and developments that we did, and in this video we shall also find out more about the properties and all the different discoveries that we can make about this exact function and the distributions that we are studying. And meanwhile there would be a lot of solved problems as well, so just head forward to the video. We can start over from there. So this integral would be something like an trigonometric integral with definite limits, and what we are going to do is we are going to introduce a very more general formula as well. And after the end of the video, what you will find is you will find some relevant content along with the video, because I do understand that it might be very hard to switch videos sometimes when you are learning, and it might be hard enough to find them. So what we have done is, for every video that we are going to make, along with the video contents, what we are going to add is the supplementary contents that are required with the video to be learned. So obviously what we are going to do is we are going to finish this problem, and then you're going to have a revisit of whatever things are required. So you can first go to that part and learn about how to do integration and stuff, and see the portions, and then come back to this integral as well. So you see the integral is given as I equals to 0 to pi by 2 sine square x dx, and this is the integral. Well, there are two ways obviously, because we know that sine square x dx has also an antiderivative, which is if you were to do an indefinite integration on this thing, you would also get an answer. But then again, if you were to do an indefinite definite integral, you would need the indefinite, right? So what we can do is as follows. We want to find out the indefinite of sine square x dx, and this would be, we would first have an 1 by 2 outside and a 1 by 2 inside, and this would be 1 by 2 into 2 sine square x dx. 2 sine square x dx is just equal to, if you remember, cos 2x has two formulas. One of them is cos 2x equals to 2 cos square x plus 1, and one is 1 minus 2 sine square x. So 2 sine square x is basically 1 minus cos 2x, not by 2 because it's already 2 sine square x dx. So this will give you integration of half dx minus integration of cos 2x by 2 dx. So this will give me x by 2. This will give me sine of 4x by 4 plus c. Therefore this definite integral is basically equal to the following thing: sine square x dx equals to x by 2 minus sine of 4x by 4 from 0 to pi by 2. We are avoiding the c because that will always be cut off, as we know from the theory. So this is pi by 4 minus 0 minus 0, which is pi by 4, which is actually the answer for the problem. So let us see what else we have in this section. Now, as I've said before, since this is a composite function, we really need to understand what is the outer layer and what is the inner layer here. So to solve this problem, define the following pseudo functions. Pseudo functions. So what are the pseudo functions that we are going to define? Let's do that. f1 of x is equal to x square. We are going to define this x square function. Well, because obviously the first thing that we see here is something squared, right? So we really need to have this, but we just don't know in which order it will come, but that we can figure out for later. The next function that you can see in the picture is also a logarithmic function, so it's like log of x. We also have an exponential function, so it would be f3 of x equals to e to the power x, and a fourth function which would be not e, it would be sine x, right? Yeah. So this is our total thing, and now we can write the function f of x as f of x is equals to, so what do we actually want to do? We want to see that the first function is the squared, the next is log, next is exponential, next is sin x, right? So our function is basically f1 composition of f2 composition of f3 composition of f4 of x. So this basically is our function. Okay, so if I were to write it in functional form, it would be something like this: f1 of f2 of f3 of f4x closing f3 closing f2 closing f1. So this would mean the actual function. Now, well, we need to be dealing with certain functions, because when we differentiate f dash x using the chain rule, these things come. So let g of x equals to f2 f3 f4 and h of x equals to f3 f4. Then g of x is also equal to f2 composition h of x, right? So we first basically would start with h of x. Now we see that h of x is equals to f3 composition f4 of x, which essentially is f3 of f4x, right? Now f3 was e to the power x, f4 was sin x. Then by using the chain rule, we can see that h prime x is equals to f3 prime of f4x multiplied by f4 prime of x, right? So this would be the meaning of this functions, right? H prime x. Now obviously this is the chain rule, and for that we need to find the derivatives for f3 and f4. So since f3 of x is e to the power x and f4 of x is sin x, we know that f3 prime x would be equal to e to the power x itself, and f4 prime x would be equal to cosine of x, right? Yes. So f3 prime x would be e to the power x and f4 prime x would be cosine of x. Therefore, the final value, the value of h prime x is given as h prime x equals to f3 prime of f4x into f4 prime of x, which means it's basically e to the power sin x into cos x. So this is our number one. So once we are done with h prime x, what we would like to go on to g of x, and f2 is basically log x. So now we are given that g of x is equals to f2 of hx, right, which is basically f2 of hx. So using the chain rule, using the chain rule we have g prime of x equals to f2 prime of h of x multiplied by h prime of x, right? So h of x was, let us check, it was I think e to the power sin x, something like that, right? Yes, it was e to the power sin x. So, and f2 is log x. So we know that f2 prime x is just equals to 1 upon x, right? Because since f2 of x is logarithm of x, where log is the natural logarithm, the derivative of that would just be the reciprocal of x, because that's the standard derivative which we have evaluated many times. Now this gives us the answer that therefore g prime of x would be equal to 1 by h of x into h prime of x, and putting the value we do get e to the power sin x into cos x divided by e to the power sin x, which gives us only cos x, right? So it's a pretty simple one this time. Now that we have g, we can write capital Fx. Finally we see that f of x is equals to f1 composition g of x, right, which can be written as f1 of g of x. Therefore using the chain rule we have f prime of x equals to f1 prime of gx multiplied by g prime of x. Okay, now since f1 is just a polynomial, since f1x is just equals to x squared, we know using the rule for the differentiation of powers of x, we know that ddx of x to the power n is just n into x to the power n minus 1. So here also we can easily write this is equals to 2x, right? And that would actually do it, because then f prime of x, which we actually wanted, would be 2gx into g prime x, right? Now what was gx again? Gx was f2, f3, f4, so it was log of e to the power sin x, right? And g prime x was just cos x. So this was 2 into log of e to the power sin x, and this was just cos x. And since you know log of e to the power sin x with base is just sin x, this becomes 2 sin x cos x, which just gives you sine of 2x, which is a multiple angle formula. It's a double angle formula here, which is our answer. So this was again a problem where we need to use the chain rule effectively. So what I'm trying to do here is to find different kinds of derivatives in order to make sure that we understand what's going on, right? Okay, let's do another one. Problem 2. Find the derivative of f of x equals to x square plus root x whole to the power sin x plus log square x. This thing is the function which we are given, and we need to find the derivative of it. Now obviously this is the problem where things start getting a little bit more difficult rather. So we need to understand what's going on first and how to solve this kind of problems in general. So as you can see in this problem, we actually have some x square plus root x thing, and we have something in exponent to that, right? So we generally do not have that, but we do have here. And to solve this kind of a problem, we need to be thorough about what we are trying to do. So the general technique for solving problems which have like this unorthodox exponents and the basis, what we do is follows. We try to take the natural logarithm of both sides because of the properties of logarithm, which transforms the exponent and it makes it a coefficient, and we can just evaluate it in terms of log. But then again, what does it mean for the actual function? So given f of x equals to x square plus root x to the power sin x plus log square x, right? And since it was given, we can see that taking log on both sides, we have log of fx is equals to log of this whole thing x square plus root x to the power sin x plus log square x, right? Now since we know that logarithm transforms the exponent into coefficients, we can write it like sin x plus log square x and let us define this as a new function. So let us say this is something like h of x equals to log of fx equals to this. Okay, so we are rather interested right now in finding the derivative of hx. So we are interested in finding h prime of x. So this is the function obviously, and it's a product of two functions, and we know from product rule of differentiation that, so the product rule says that if fx is equals to f1x into f2x, then f prime of x would be equal to f1 prime x f2x plus f1x into f2 prime x. So we can use that to our advantage to find that the derivative of hx ddx of sin x plus log square x into log of x square plus root x plus so this is the derivative for h prime x, right? So let me find out that obviously when finding the derivative of sin x plus log square x, the derivative of sin x is pretty much simple, but the derivative of log square x is again a composite function. So let us define like this: let p1 of x equals to log square of x, which we want to find, and for that let us define two more functions: p11x equals to log x and p12x equals to x square, right? Then p1 of x is just p12 composition p11 of x, because it is just log of x whole squared, right? So this would mean that this is equals to p12 of p11x, and by using the chain rule we have p1 prime x equals to p12 prime of p11x into p11 prime of x. So what is p12 prime x? So we know that since these are basic derivatives, we can list them out collectively, that p11 of prime x is just 1 by x and p12 of prime x is just 2x, right? So therefore p1 prime x would be equal to 2 times 1 by x it won't be 2 times 1 by x, because p11x is just log x, so 2 times log x, and p11 prime x is just by x, so it's like 2 log x by x. So this is our p1 prime x, right? So this is one of the functions we wanted to evaluate, and another function we want to evaluate is log of x square plus root x. So let's just evaluate that as well. Let q of x equals to log of x square plus root x, and we define q1 of x equals to log x, while q2 of x equals to x square plus root x. Then we have q of x equals to q1 composition q2 of x, right? So this would mean it is basically equals to q1 of q2x, and by using chain rule we have q prime x equals to q1 prime of q2x equals to and let us do this later, because we first need to find out the derivative for q1 and q2. So by basic derivatives we know that q1 of x derivative is just 1 by x, and for q2 of x we have d dx of x square plus root x, which basically is 2x plus, and the derivative for this is basically 1 by 2 root x. So this is the derivative for q2 prime x, right? So what we do get is this. Therefore q prime of x is equals to, so 1 by q2x, q2x was 1 by x square plus root x, so 1 by x square plus root x multiplied by 2x plus 1 by 2 root x. So once we simplify this, what we get is something like this: 4x to the power 3 by 2 plus 1 by 2 root x whole into x square plus root x. This is the derivative for qx. So once we have completed our qx and our p1x, we can find out the derivative for h prime x now, which is not really that hard. So what we can do is this. We know that h prime x is just equal to sin x plus log square x into d dx of log of x square plus root x, and plus d dx of sin x plus log square x into log of x square plus root x, right? Now this is the derivative of log of x square plus root x. This is 4x to the power 3 by 2 plus 1 divided by 2 root x whole into x square plus root x. So what we do get is this: sin x plus log square x into 4x to the power 3 by 2 plus 1 whole divided by 2 root x into x square plus root x plus, and the derivative for this is basically cos x plus 2 log x by x into log of x square plus root x, right? Now this is the derivative for h prime x, but we actually wanted to find f prime x, and we do remember that we had defined h of x equals to log of fx, right? So to find the derivative, we see that h of x is basically equals to h1 composition f of x, where h1 of x is just logarithm of x, right? So by chain rule, h prime of x equals to h1 prime of fx into f prime of x, right? And since h1 is logarithm, the differentiation of logarithm is 1 by x, we can say this is basically 1 by fx, and this remains f dash x, as we do not know f dash x yet. So this becomes f dash x by f of x, right? So we see that therefore f dash x should be equals to h prime of x into f of x, and to quote the whole answer, we can write the final answer is f prime of x is equals to x square plus root x to the power sin x plus log square x multiplied by sin x plus log square x into 4 x to the power 3 by 2 plus 1 whole divided by 2 root x into x square plus root x plus, so the next term was cos x plus 2 log x by x into that. So cos x plus 2 log x by x into log of x square plus root x. This is the final answer. So as you can see, differentiation of that function x square plus root x whole to the power sin x plus log square x was a tad more difficult than we would have thought it would be. But then again, differentiation is sometimes tough. Yes. So this kind of problems might appear in your competitive examinations, in your college examinations, in some platform where you solve problems. But the steps that I have followed here, all of the steps, they are necessary for a complete solution. Otherwise it's just second guessing the solution. So we really need to do all of this. Obviously you can do it in one line. If I wanted to, I could have done in one line, but that's just my thought process, right? So but when you're doing it in pen and paper, you need to write every piece of your thought which makes sense logically, and why a step follows after the next one, and why nothing is obvious. So you just have to explain everything. So you just cannot use the chain rule blindly. So you need to provide explanation for why each and every step works, why the derivative of such a big composite function would result in finally something like this, right? Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.